This video lecture on recursive descendant parser. So what is this recursive descendant parser? A recursive descendant parser is a top-down parser. So it is built from a set of mutually recursive procedures where each procedure implements one non-terminal in a given grammar. It is a top-down parser. It uses the recursive procedure. There is no backtracking and no left factoring or no recursive grammar is allowed in recursive descendant parser. So the rules is that you will be given with a set of productions, which means the grammar. If the input is a non-terminal, then write the procedure or subroutine or recursive function. If an input is a terminal, compare it with the input symbol. If both are equal, then increment the input pointer. If any non-terminal has multiple productions, write all the productions into a single procedure. No main, no definition. Thing is that non-terminal, if you find any non-terminal in a production, just write the procedure or the subroutine. If you see any terminal symbol, then we need to compare it with the input symbol. If both are equal, move on to the next input symbol. Very simple. Okay. So here this is the recursive descendant parser for the given grammar. So here we have taken one grammar, which is a very common example. When you see the non-terminal symbols that we have here is E, E dash, T, T dash, F. So we need to write the procedure for all the non-terminal symbols. So E dash, E procedure for E, I'm writing the procedure as E of. Procedure is nothing but the function. So how we will write the function? Function name followed by open bracket, close bracket, same thing. E, I'm naming the procedure as E open bracket, close bracket. E dash, I'm naming it as E prime. T, T off. T dash, T prime off. Then F, F off. Okay. Then look ahead is the next input symbol. Match if it is matches with the current input symbol, then advance to the next pointer. Roughly, your main function will look like this. Look ahead equal if it sees a look ahead, get the next token. Where we will need to we need to start from the first production. So what is my first production that we have here? So my first production is E tends to T E dash. So this will be my first production. So what is the first non-terminal? What is the starting point of my non-terminal or the start symbol of my entire grammar? It is E. So we need to include E of. Okay. So if the look ahead is end of file, parsing is successful, else extra input is found. So these are the procedure for the procedure of E dash. Sorry, for the procedure of E. So my production is E tends to T E dash. So here what is the first symbol we have? T. Okay, which is a non-terminal. Just write the function here, which means the procedure here. What is the next one? E dash. So how we name the function for E dash? E prime. Write that along. See here, E tends to T E dash. T non-terminal, include the procedure for T, T of E dash. Again it is a non-terminal, include the procedure name of E dash, that is E prime. My next production is E dash tends to plus T E dash or epsilon. What is my first symbol here? Plus. So if the look ahead equal to plus, match with plus. So here this is my procedure for match. If look ahead equal, how we will write the procedure for match means match of token x. If the look ahead is equal to x, look ahead equal to get next token, else error. So here how we will be calling this function? Match of plus. So plus will be passed here. So x will be holding plus. If look ahead equal to plus and match equal to plus, then go for the next token. This is how we will define the procedure for plus. Okay. Plus means immediately whenever you see the terminal symbol, just call the match function. Inside the match function, we have written what to do, which means that if you are looking for any of the terminal symbol, just move ahead with the next symbol. What is the next symbol on? What is the next value on my production E dash? After plus we have T. T is a non-terminal. Just include the procedure call for that T off. What is next symbol? E dash. E dash. Just call it off. What is the next one? Just give the procedure name for E dash, that is E prime off. What is the another one protection that we have is epsilon. Else, if you see for the first symbol plus, you have to do all these things. If, see two protections we have, we need if else. Okay. And what is the another protection that we have? Epsilon. Since it is an epsilon protection, have the empty else part, do nothing. Okay. What is my next protection that we have? T tends to f t dash. What is there? F and t dash. So include the procedure of f of semicolon, and include the procedure of t dash as t prime. Okay. What is the next protection that we have? T dash tends to star f t dash or epsilon. So again, what is the first symbol in this one? It is star, which is a terminal. So if it is a terminal, just make a call to the match function by passing the terminal. So if look ahead equal to star, equal to star, match star, call that match function. Okay, and this match function will take care of it. And then what is the next one that we have? Terminal, sorry, the non-terminal f. So just include the procedure for it. Again, next one is the t dash, which is a non-terminal. Just include the procedure call for it. And this production also includes epsilon. If it is an epsilon, in the else part, just leave it empty, do nothing. The last protection that we have, f tends to open parenthesis, e close parenthesis, or id. Okay, so we will write it. F tends to, what is the first symbol here? Open parenthesis, which means terminal. Terminal means if look ahead equal to open parenthesis match with, we need to call the match function by passing that particular terminal. What is the next symbol we have? E. E is a non-terminal. Just call that procedure E. What is close parenthesis? Next one is the close parenthesis. Close parenthesis means again it is a terminal. So just match of terminal, call that match function, match procedure. Else if we have another thing. Okay. So else if we have an ID. Okay. Else if we have an ID. So if look ahead equal to ID, what we need to do? ID is an terminal here. Match of ID, just call that match function, match procedure by calling ID and close this. And we have also included the error part. If none of this production comes, we need to include the, or we need to call the error. So this is how we will write the procedure for recursive descendant parser. Recursive itself is nothing but recursion. Recursion is nothing but calling the function by itself. Here the function is nothing but the procedure. So based on the grammar, the procedures will be called accordingly, or the same procedure will be called by itself. That is why we call this as the recursive descendant parser. Okay, so here just check here. I have given one example here. This is my string. These are the procedures which we have. I'll tell you how this procedure will be working. If my string is id plus id dollar, then see to my procedure. First, this one will be called. When you check in the previous one, we have a main. Main will be starting from the, so main will be starting from the first symbol. Am I right? Okay, in the main, what is the first, which is my start symbol? E. So if all automatically your entire execution will start from the first procedure E. So in the first one, first this will be called, then the first line we have T of, so input symbol is ID, then it goes to T procedure, then we have F. From here it makes a call to F, then it goes to F. What is the first one? It checks for this if, does it matches? No. It goes to this, what is that? Look here actually, ID. Match ID means it goes to the match token, match procedure. If the look ahead equal to ID, then look ahead equal to get the next token. So what is the next token here? The next input symbol is plus, set input symbol is plus. Have that look ahead as plus here. After this entire procedure is over, now this entire F procedure is over. After look ahead match ID, it is over. So it sees the close bracket here. Once this entire procedure is over, it sees the close bracket. When it sees the close bracket, it moves back from where it is called. From where it is called, here it is called. So it moves back. What is the next one that we have? T prime. So this means it will come to this part T prime. Okay. So what is the next symbol that we have? It is, just make it a star plus here, right? See here. What is the next symbol? Plus. Look ahead, this T prime is going to handle star. So this will become false. So then come to the else part, just return. Return means where it will be written. Return to this part. Okay. Right. So here it will return here. Since this is a close bracket, it comes to the function from where it is called. From where it is called. Here. What is the next line? We have E prime. So this E prime procedure will be called, this will be called here. What is the first statement? If look ahead equal to plus. Yes, definitely the look ahead equal to plus. So it matches with plus. So it calls the symbol, which means it calls the match procedure. Then it will be executing and it will be written here. What is the next symbol? What is the next symbol? Look ahead equal to get next token, which means it will get the next token. What is now? What is the look ahead? It is ID. Okay. Now what is the next one? We have T off. From here it calls the T off procedure. What is T off? T procedure. In that the first line is F. So F T off procedure is called. Next one F procedure is called. It goes to the F procedure here. And what is the next symbol? This particular if will be false. It moves for the else if look ahead equal to ID. Then it calls the match function here. What is the next symbol that we have? Input symbol is ID. So it will be matched here. And it moves back here. Then we have the T prime here, T prime. So which means this function will be called. Then if condition will be false, else here. So else means return. So it returns to T. So T here we have the close bracket. So from where it is called, this comes here. From here it is called. So it comes back here. It now what is the next statement that we have? E prime. So what is this E prime? Again the self statement will be called, right? And then what is the next symbol? Actually we don't have any next symbol. Oh, okay. So then the next symbol is nothing but a dollar. So here it doesn't matches with this plus. So it comes to the else part. Else we have the return statement here. So it returns to from where it is called. From here it is called. So it returns back to this E procedure. And after that what we have? We have the close symbol. Okay. So it reaches the end. After reaching the end, if the input string is empty, since yes the input string is empty, which means the look ahead as of now it is dollar, which means it is empty. If it is empty after reaching the end, I can say the entire string is accepted. Clear? This is how we will be writing the procedure for recursive descendant parser when a grammar is given, and how this is how the string will be matched. Thank you.